Alright, so in this video we're going to be talking about applications of trigonometric functions. And what this means is how do I actually use trigonometric functions, sine, cosine, tangent, secant, cosecant, cotangent, in the real world. So to do this, we're going to do a couple of word problems as our examples, starting with this one. So Kyle uses a clinometer, which is a tool that measures the angle of elevation, to measure the angle to the top of a tall tree. He has measured the distance from his spot to the tree and knows that it is 50 feet. The angle of elevation is 50 degrees. What is the height of the tree? Okay, so first of all, we're going to start by defining the angle of elevation. So this is the angle of elevation. And the way we find this is we use a tool such as a clinometer to measure, and basically what it does is it finds, you look through it to find the top of whatever it is that you're measuring, and it'll give you an angle from that. So it also makes a right triangle. That's this right here. So this is 90 degrees. This, as we found from the word problem, is 50 degrees. And this is 90 plus 50. That's 140, so this is 40 degrees, but that's not very important right now. You could use that, but for this problem, we're not going to bother. So we're going to treat this as theta, because we have this distance, which is 50 feet, and we would like to find this height. So we're going to call this x. So if this is theta, this is the adjacent, and this is the opposite. So we have two options that will make our life a whole lot easier. We can use tangent, or we can use cotangent. Personally, I prefer to use tangent, and you'll see why in a second. So tangent of 50 degrees is equal to, tangent is opposite over adjacent. So the tangent of 50 degrees is equal to x over 50. We could have set this up as cotangent of 50 degrees, but number one, there is not a calculator button for cotangent, and also, whoops, actually these would have been flipped. So it would have been 50 over x. If you do this, you're going to have to multiply x and then divide by cotangent of 50. But if you do tangent of 50, all you're doing to isolate the x is multiplying by 50 on each side. So you end up with 50 tangent of 50 degrees equals x. So we can just go ahead and plug that into our calculator. So you're going to do tangent of 50, and if you go into your mode, you want to make sure it's in degrees for this problem, so you do tangent of 50, you get 1.91 times 50, you get about 59.6 feet. X equals 59.6 feet. And that's our answer for this one. Alright? Alright, so now we're going to move on to our next example. Kyle, the dedicated trigonometry lover, is now trying to find the distance that he is from the tree. He knows the height of the tree, which is 85 feet, and the angle at the top of the tree, the angle of depression from the top of the tree, which is approximately 10.15 degrees. How far away is he in miles? So in this case, Kyle knows that this tree, this height right here, is 85 feet. And he knows the angle of depression. So if you remember from the last problem, this is the angle of elevation, which means that this is the angle of depression. So this is 10.15 degrees. And we would like to know how far Kyle is away from the tree. So what's different here from the previous problem is that theta has moved position. Now instead of the angle being at the bottom, so to speak, it is the angle at the top. This doesn't change much, just the position of theta. So we need to find this. We know that this is the adjacent side, and this will be the opposite of theta. Okay, so we're going to use tangent once again. So tangent equals opposite over adjacent. So we're going to do tangent of 10.15 degrees equals x over 85 times 85 on both sides to isolate the x. So we have 85 times tangent of 10.15 degrees equals x. So now what we can do is plug that into our calculator. I'm going to turn the calculator on. We want to do 85 times tangent of 10.15. And I already know that my mode is degrees from the last problem. So we get that he is about 15.22 feet. So I'm going to use the approximation here to write down in my work. But when I go to answer the question, which requires a conversion, I'm going to use the number that was saved in my calculator because I want it to be more exact. So now we're going to have to do a conversion table. So we have what we start with, which is 15.22 feet. And we know that to cancel out the feet, it also has to be feet down here. So we're converting from feet to miles, and I know that there is 5,280 feet in 1 mile. So if you remember, these two cancel out. And anything in the top is being multiplied, and anything in the bottom is being divided. So we get that 15.22 over 5,280 equals about 0.003 miles. So I'm going to write So in this case, it's not very practical to think about Kyle's distance in miles, but what we're doing here is just remembering to answer the question. And a lot of times, conversions are used to confuse you. So just make sure that you will always look back and make sure that you are answering the question. Kyle is now trying to find the angle of elevation. He knows that he is 5.02 feet from the tree, which is 0.15 miles tall. What is the angle of elevation in radians? So I can already see a discrepancy here. We have feet and miles, and that's not really going to work out because feet and miles are different units of measurement, and when you're dealing with trig functions, you really need the units to be the same, otherwise it'll totally mess you up. So we have Kyle back over here again, alright, and this is once again the angle of elevation that he's trying to find. We'll call it theta. It's not a very good theta. There we go. Alright, so this is still a right angle, and you already know without me drawing it, I'll draw it again. Draw a different kind of tree this time. So, those are really bad roots, but he is 5.02 feet from the tree, and the tree is 0.15 miles tall. So the first thing we need to do is convert from miles to feet, because miles, here we have a fraction of a mile, and that does not seem very practical, but over here we have whole feet. So we're going to do 0.15 miles, and then 1 mile is equal to 5,280 feet. So here the miles cancel out, and as you remember, the things in the top get multiplied, and then this, they get divided by this, but since it's 1, we're not going to do that, because anything divided by 1 is just the number itself. So I'm going to get my calculator up. Alright, so I have my calculator open. We're going to turn it on. Do 0.15 times 5,280, and we get 792 feet. It's nice that that's an exact number. So over here, we're going to write 792 feet. So we don't really need the miles anymore. Alright, so we're trying to find theta, and we now have the opposite of theta and the adjacent, which is lovely. We need to remember, of course, that the question asks for it in radians, but practically I really do like thinking in degrees, because you are taught degrees from the beginning. I can imagine that in my head better, so I am going to find this in degrees and then convert it to radians. Of course, you are welcome to find it in radians from the start. Okay, so we have tangent of theta, oops, equals the opposite, which is 792, over the adjacent, which is 5.02. Okay, and now we have an issue, because in the other ones we had an x that we just multiply by a tangent. In this case, what are we going to do? So this is where inverse trig functions come in handy. And an inverse on your calculator will look like tangent -1 or sine to the -1 power. And this means like the inverse. So we are going, the way you use this would be, you would do tangent -1, or the inverse of tangent 792 over 5.02. And then it will spit back out at you the actual angle measure. So on my calculator again, I'm going to do second tangent, the inverse of tangent, and if you notice, the inverse is, okay, so we have the inverse of tangent, and if you notice, all of the inverse functions are above the original function. You just have to hit second and then the function you want the inverse of. So in this case, we wanted the inverse of tangent, and this is different than the reciprocal functions, so tangent -1 is not equal to cotangent. There is an important distinction there. So 792 over 5.02, and you get about 89.64 degrees. So we 89.64 degrees. Whoops. And the approximation is okay to write here, but when we go back into our conversion table, we're going to use the actual number that was in the calculator. So to convert from degrees to radians, we're going to do a similar thing to what we did over here, but here we're going to do 89.64 blah 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 degrees. And then in 1 radian, there's 180 degrees, so that is in, not in 1 radian, in pi radians. So we can cancel out the degrees, and don't forget that this will be, you divide this by this, and then to keep our answer slightly more exact, we're going to leave pi as is. So if you plug that into your calculator, you're going to do that divided by 180. You get about 0.498. And this looks pretty wonky, so what I would ordinarily do is I would go to math, enter, try and find a fraction. But in this case, because I've solved this before, I know that there is not a fraction that will go with this, which is kind of sad, but it still works, because if you think about it, one of the radians that we use that's on the unit circle is like pi over 2. If you think about it, that's really just equal to 1/2 times pi, and over here, what we're doing is a similar thing. It's just what's being multiplied by pi is a decimal, and that looks pretty strange, and it is pretty strange. You just wouldn't find this on the unit circle. If you really wanted to be able to find this on the unit circle, 0.498 is about equal to 0.5, which is 1/2. So if you wanted to be able to find this on the unit circle, it'd be right around pi over 2 radians. So this is your answer for this question, and we know that's the answer because we have the angle of elevation and we have it in radians. Once again, this is the angle of elevation, so we can over here put 0.498 pi radians. Alright, so now Kyle is trying to find the angle of elevation of a slide. He knows the slide, which is totally straight, which is kind of odd, is 15 feet long. He also knows that the ladder is 6 feet tall. What is the angle of elevation in degrees? Okay, so this will look, once again, like a right triangle. And the ladder makes a 90-degree angle with the ground, because if it didn't, we wouldn't be able to use these functions in this way. So here's the ladder. Ooh, it's not a very good ladder, but there's the ladder. this is the slide. So this is 15 feet, and the ladder is 6 feet. Here's Kyle, trying to find the angle of elevation. Oops, he's kind of in the ground for some reason. But the angle of elevation we said is this, so we'll call this theta. And we know the opposite of theta and the hypotenuse. So if we use SOHCAHTOA, we can eliminate tangent, because that doesn't make any sense, we don't have the adjacent. We can also eliminate cosine for the same reason, because once again we don't have the adjacent. So we're going to use sine here. So sine equals opposite over hypotenuse. Alright, so we have sine of the theta equals 6 over 15. Okay, so in this case, we are going to have to use the inverse function. So arc sine, you don't really fully have to understand these for this video, but basically on your calculator, this is all you need to know about it. On your calculator, it is sine to the negative 1 power, which indicates that it is an inverse. So what you do is you plug in the sine value of theta, and then it will give you theta back. So I'm going to pull up my calculator. Okay, so we have the calculator here. We're going to do, turn it on. We're going to do second sine, there's the inverse, and we're going to put 6 over 15, which if you've noticed would actually simplify down to 2 over 5, but that's not very important, it'll give you the same answer. So we have gotten a bit of a weird answer, and the reason for that is because I left my calculator in radians, so we're going to switch back to degrees, something you always need to check, and hit enter again. This makes a lot more sense. We have, although you could have 0.41 degrees, but that's just not a common thing. Okay, so we get about 23.6 degrees. Theta equals 23.6 degrees, and we check back over here to see does that answer the question, and it does, because it is the angle of elevation in degrees. So this is the answer here. That concludes this question. Yay! Thank you for watching this video. I hope you learned something about applying trig functions in the real world. Bye!